Hi there, I'm Ashley Mills and I'm going to show you a prototype mushroom growth controller that I've been working on. This is the controller here. Now I designed this first on a breadboard and then got it made onto a PCB using the kind of hobbyist service Hackvana. I can tell you it does a fantastic job actually in making these things. I soldered the components myself, but got the 10cm by 10cm boards made up by Hackvana, and it was, I think, $39 US, including land mail shipping, for 10 by 10cm boards, 2-layer boards, which is very good actually. I paid for the EMS shipping to get it quicker, but it was a very painless process and everything worked out fine using KiCad's default output files. I think I renamed the outline file to rename the extension, but that was it. So you can't really see the display there, but if I put this piece, I can see it, but you can't see it on the camera. There's two outputs here, which is the bottom one is the temperature, which is being displayed or read by this sensor, which is a Dallas D18B20 one-wire digital temperature sensor. So it's about 20 degrees in this box here. At the top output displays a humidity, and this is a DHT5, one of these temperature humidity sensors down here, and you can see that. And this is another sensor. Now you might wonder why I've got a temperature and humidity and a humidity sensor, like a temperature sensor and a temperature and humidity sensor. Well, the reason for that is I wanted this one-wire digital temperature sensor is really nice and is reasonably accurate, whereas the temperature sensor on this is not that accurate. So I kind of wanted two. I've found a very low profile package that does both to a high accuracy, but it doesn't come with kind of a molding like this. So this is one of the problems, or the problems I'm working on at the moment, I guess, or an ongoing problem, is to find a good combination of temperature and humidity sensors that is cheap, because I want this to be as cheap as possible but accurate enough. I've actually got 2 digits of precision here, which isn't really needed, but maybe you want to display something else on here, for example, because the temperature is only accurate to ½ degree anyway, plus or minus ½ degree, so I really don't need 4 digits for the temperature there. Now, what I can do to program this is, if I hold down this button here, it will go into programming mode, and it's set. The set point is set to 5 degrees, and I can just, by pressing these buttons, I can adjust the set point, and I'll move it up to 22 degrees. So you can see that the set point is 22.5 degrees. Let's okay, so it's at 24 degrees. And I don't know if you heard it, but the relay clicked on at that point. So this relay down the bottom clicked on, which I've had to, please accept my apologies, crudely attach here, because the barrier system screw terminal didn't arrive yet, because when I ordered all the parts from Farnell, I didn't realise that it was an American part, so I had to pay £15 shipping for it extra, and so, but they haven't arrived yet. But so in the future version, I'll look for a UK supplier for something alternative. There was actually a fault on this board, unfortunately, in that I wanted to do this because this is the first PCB I ever made. So I wanted to kind of make it a little bit challenging for myself. So I added on each of these 7-segment displays is controlled by a separate shift register, 595 shift register, which are all chained. And but what I didn't do was put in any current limiting resistors to the LED segments. This is because at the time, which was probably 6 months ago, when I was kind of reading through this, probably not 6 months, let's say 4 months, I I looked at the 595 spec sheet, and I saw that it said that each output could be plus or minus 7 milliamps, either sinking or sourcing current. I thought that meant that it was current limited to 6 or 7 milliamps, to plus or minus 7 milliamps. It's not current limited. You do need current limiting resistors. Now, so the problem here is that there's too much current being drawn through this regulator, and this regulator is getting too hot. And the display will probably burn out reasonably quickly as well. I think what I will do is I'm going to use pulse width modulation to control to control the brightness, and I'm going to multiplex a 4-digit display, or maybe a 3-digit display, just using the CPU. I might not use pulse width modulation for brightness. I might actually have have a transistor on the cathodes, an NPN transistor on the cathodes of each of these segments, and then control those, each one in parallel, so I can control the brightness in software. I still have to have the current limiting resistors. In theory you don't. Like, you could say if 5 segments are on, then limit the current so that they're driven in hard parallel. But slight differences in forward voltage and so on could mean that it leads to burnout. So it's still better to have the series of resistors. So the CPU on here is an ATmega 328P AU, which is a TQFP28 format package Arduino essentially. And you can see the crystal there, some kind of decoupling capacitors. There's 2 switch banks which are driven with 3. They're connected in parallel, and each one has a resistor, so that what you have is 3 resistors in parallel. And then depending on which ones are pulled to high, pulled to 5 volts, you then get a different current, of different voltage drop, and a different voltage going into the analog pin of the CPU. So you can actually only use one analog input and have any combination of 3 buttons. Now, one thing I will say about this is when I did this on a breadboard, I used values of 3K, 2K and 1K. And this actually created enough spread that I could easily tell the difference between any combination of those switches being on or off. Now, but when I transferred this to the board, the resistance of the breadboard with all the wires and everything was different to on the board, and then the spread is now much narrower. So I would probably use different values in order to get a wider spread. I kind of just did it. I didn't even calculate the values. I just did it. I just plugged them into the breadboard and checked. And what I could do is actually plug them into this and try and find a good spread, which is probably a more pragmatic way to do it, considering that there can be such big differences depending on the wire traces. I mean, they won't on the PCB, but you know, I may as well just do that. Then there's the 3 relay outputs. So it's got sockets for inputs, and that's where the digital temperature sensor's connected, and there's some other sockets as well for, say, I2C. And I will put proper connectors on the next version of the board. And I'm thinking of changing the CPU on the next version of the board to something like an LPC 11U24, so a Cortex M0, and going to a kind of ARM to give myself more RAM and flash and so on. I might add on an ESP, the new ESP Wi-Fi chip. I don't know if you've seen it. I've got one here actually. Excuse the mess of my board. This camera seems to take so long to focus on anything. You know, I'm trying to... There we go. Now that is actually a little Wi-Fi chip. So I might put that on the next version of the board, increase the amount of available RAM and so on, and have a connected controller. Right, now... So... this is now trying to control the temperature to 24 degrees. At the moment, obviously the heating element is here. Now let me tell you about the heating element, because this is really important. I was thinking about making this controller for growing the mushrooms, and I was concerned about, you know, what heating element could I use. I thought about, there's various options on the market. You know, you could use a terrarium heater, a ceramic heater, one of those kind of carbon fibre mats from Habitat or someone like that. But they tend to be quite expensive. They tend to be 240 volts, and they tend to, although I'm sure you could put different voltage through them actually, but they're quite expensive. They're probably £20 for a decent heater. And I don't know, it was really strange. I started looking about how I was actually looking at how to make organic LEDs, and I came across this guy on YouTube called Robert Murray Smith, and he had all these fantastic videos about how to make various things like solar cells, and a lot of it was surrounded around how to make graphene. Because what I was actually looking for is a way to coat glass with a conductive material to make organic solar cells, just as a personal experiment. And that's where I came across his graphene stuff, because he was talking about coating glass for other things. And the really strange thing is, so this guy, Robert Murray Smith, I was looking at all his videos, and I saw that he sold this ink, this conductive ink, a heat resistant conductive ink. And I thought, wow, that's really interesting. That's amazing even. You know, that's so simple as a way to design a heating element. And now here's the strange bit. So I looked on the website for where I could buy the ink from his company, Forward Working Group. And it turned out he was just a mile down the road from me. His lab was a mile down the road from me. And so I sent him an email and said, you know, can I come and say hello? Because he'd posted actually an open invitation to people who'd supported his Kickstarter campaign to come down to his lab and speak to him. So I went down to his lab, and I can tell you he was a really open and genuine guy. You know, the things he said on his YouTube video were true. And I was just amazed, you know, how incredibly intelligent and how incredibly resourceful this guy really is. And I told him what I was doing. Like, this was one of the ideas, the mushroom growth box, and another idea was a brewing box, you know, for putting in fermenting vessels and things like that. And he said that he thought the idea was a great idea, and he actually gave me some of his conductive ink for free. You know, and this is the kind of guy he is. Like, if you're genuine, he is a genuine guy, and he's willing to help people. And I think that is fantastic. So I got hold of some of his ink and took a piece of MDF. These aren't the best materials, so just bear with me. But in any case, took two copper strips. Now, what you can use for this, or what you're probably better to use for this, is just buy copper tape. Now, you can get copper tape from garden centres. I had to buy it online on eBay. I think it was a couple of quid for a couple of rolls of it, for like 10 metres or something, maybe more. And that would be the best thing to do. But what I did was take apart a lithium-ion battery, because I'd seen one of Robert's videos where he takes apart a lithium-ion battery, and I just thought it was really interesting, and I wanted to see if I wanted to do it myself. So I took apart a lithium-ion battery and took out the copper in there. Then I can't remember how I stuck it. Oh, I put tape on the back and stuck it to the MDF board. Then I painted on layers of this conductive graphene ink. And these are in this ladder formation. This was Robert's idea, to put it in a ladder formation. And it seems to work very well. Now, so what am I putting through here? Well, this is connected, so the board is just driven off 5 volts. So all of the control electronics are on 5 volts. Actually, there's some of it's on 3 volts because of that regulator. But the next revision will probably just all be 5 volts. Then what I have, there's going to be these terminal blocks here. I don't really know the best way to connect up these terminals, like whether or not you have a power input in one location and then just have a switched output. In my case, this is just acting like a switch, like a single pole, normally open switch. So through the wiring, this directly connects to my voltage source, my power source. And you can see the power output on the left here for the board. And I've set it to 10 volts. And you can see it's drawing 2.36 amps. So that's 23.6 watts, right? Power is amps times volts, current times volts. Yeah, so 23.6 watts. So we've got a 23.6 watt heater here. That's quite a powerful heater actually for such a small box. I could probably run this off 5 volts and still maintain an even temperature. Now when I started doing this, what I think is worth understanding, if you're thinking what the hell is this guy doing, about my personality is, if I feel I need to learn something, I will just learn it. And I wanted to learn how to build a PCB. I wanted to do that. So most of my time was spent building the PCB. So Robert had some great ideas about how to control the this output, essentially just using a bimetal strip and configuring it for the box size and configuring the power supply and so on so that it would work, and it would be very cheap. You just have a bimetal strip, a power supply, and this. Whereas of course I wanted a kind of all singing all dancing complete control system, and that's because most of my skill set is based around software and connected software. I worked for Vodafone Research and Development for a number of years, so connectivity is really where I guess one of my strengths are, and I wanted to make a connected product so that you could have your mushroom controller and it could be sitting out in the garage or wherever it is, and you can look online and control it and monitor it and things like that. So that's really my goal, and will probably be the goal of the next board. So kind of I couldn't go down that route that Robert would have gone down. You know, it's a very simple and elegant route to go down, just using a bimetal strip. I wanted this controller, and I spent the last 3 months learning how to make a PCB, and I built a PCB. And I'm really pleased I did this because I realized it was actually very easy to do. As I said, there is a design fault on that revision, and I'm going to make a new revision. And what I will say is, if you go on IRC channels like Hackvana, people are very, very helpful on there. There's a guy called Nick Johnson's very helpful. There's many other very helpful people on there. The people that do the smoothie board, that guy's on there, and you can get loads of great advice about how to build your board, and people will even help look at your board and things like that. I didn't show anyone the schematics, so no one's to blame for that except me, like the fault with the non-series resistors. So we're preparing this with 23 watts. Now I've tested this, and I've tested this with the lid on of this board. This is just an MDF box I made, and I insulated it with a kind of reflective bubble wrap, foil back bubble wrap, and it works, and it keeps the temperature stable. I added a kind of basic hysteresis algorithm in there. You know, hysteresis is just a way to stop ping pong around a fixed point. So if you don't want, what you don't want to happen is that when it reaches temperature, the relay switches off, and then the temperature drops a tiny fraction, the relay switches back on, and you're kind of ping-ponging around. The term ping-pong, I don't know where it comes from, but it's used a lot actually in mobile phone networks, in handover algorithms between cells, because you have a similar problem effectively, that when you hand over between cells, you don't want to keep switching back to the other cell, because there's actually quite a lot of variation in the signal strength. Anyway, it turns out with this, there's so much lag anyway when you switch the heating element off, because it's still radiating heat, that you don't really have any hysteresis problems anyway. But still, I do have like some basic kind of hysteresis in there. You know, I think essentially what I do is I just, once it hits the set point temperature, it won't turn off. It won't turn off again until it's half a degree below the set point temperature. And I think it actually goes half a degree above the set point temperature before it turns off or something like that. So you end up And it seems to work very well, actually. I need to get this connected up and logging to see how stable the temperature is over time. But I think with such an insulated box, it's probably very easy to get a temperature. Now, of course, what I want to do, and which was kind of where I wanted to get to in the first place, but got distracted with making the board, because I didn't want to have to work with a breadboard and it was difficult to work with. I wanted something I could easily control. Now what I want to do is make up, I've got enough paint to make up different size boards and experiment, set up a few boxes, make up a few more of these boards. I've got 10 PCBs, and set up a few experiments to see if I can, for example, just use a single 5-volt power supply to keep a box like this hot. And I can, it's cold outside at the moment, so I can actually control it. I can put it outside, for example, and see how it deals in a cold environment, because I really want to see what the flexibility of this system is in practice. Right, that's about it really, about all I can say. I suppose one more thing, I put on this board you can see there's I've got a serial connection there, just on a breakout, and there's an in-circuit serial programmer, and I've got an AVR Dude serial programmer. And so I can just monitor the output here. On this serial output, and you can see, for example, it's outputting the temperature, and I can upload new programs and so on. So it's very easy to sort of upload new programs and get on with working. Alright, that's about all I want to say about this. But one more thing I want to say is, so what is this used for in terms of mushroom growth? Well, here, for example, is some chicken of the woods that I tried to grow. This was cloned from a piece of chicken of the woods outside. Unfortunately, it got contaminated. You can see my laminar flow hood there, but this got contaminated probably because I took it from outside, but there could be many other reasons. I really need more space and so on to do this. But it did kind of grow, and I think, but it got contaminated. In any case, so this was transferred. The chicken of the woods was first grown on grain, and these are, for example, these are some mushrooms grown on grain. This is a spawn for shaggy ink caps on grain, and then I transferred them to wood chip. Now, in order to get what you want to do, in order to minimize contamination, you really want to create the conditions that are environmental conditions for the mushrooms, so that it favors the mycelium you want to grow, so that you give contaminants no chance. So one of the things there is temperature. If you know what temperature they want to grow at, or that they grow fastest at, then you set it to that temperature and you're giving them a good advantage. Of course, you might be setting the temperature to a temperature where bacteria and other things are also favoured, but this is always a risk. This is why with mushroom growing, in this case where they're immunologically naive, as Paul Stamets, to use a term coined by Paul Stamets, then you really need to kind of use something like a laminar flow hood to get sterile conditions, and you need to kind of keep control of the contaminants in your house. Right, so this was chicken of woods. Here's some shaggy ink cap, and like here is a reishi that I grew. I don't know if you can see that. Unfortunately I didn't have the right conditions to fruit this properly, but this is a piece of reishi that I grew, and there is a block. There was no contamination there, that worked perfectly. The only thing that didn't work is I needed a temperature and humidity controlled environment for the fruiting chamber. So I want this to be versatile and be able to act as to control a fruiting chamber as well. Because then you can set up the incubation chamber, which is this, and the fruiting chamber. And because we've got a humidity sensor, we can then control either something like an ultrasonic pump to generate humidity, or a sprayer or something like that, in order to control the humidity. One of the other things you probably want in a box like that, you definitely want actually, you want to be able to control the CO2. You need fresh air exchange when you're growing mushrooms, including in this box, and especially in the fruiting chamber. So probably you want that to be filtered if you're in like a dirty area. Yeah, you definitely want it to be filtered. And so what I could do is have another sensor there, a CO2 sensor. but then the cost goes up. But you know, these are all things that could be done or could be optional on this board. I'm making this board open source, and so I really want to make this so that this kind of technology is available to everybody, so that everybody can grow mushrooms if they want to grow mushrooms, or control their brewing box if they want to control it. And it should be cheap and it should be easy to do, and especially if you're using something like his Robert's ink, because this is probably a couple of dollars or a couple of pounds to make one of these elements, and this is really cheap compared to, say, the 15 or 20 pounds for an element. By the way, this is covered in a kind of plastic wrap. Probably the surface there is about 40 degrees at the moment, so it doesn't really get dangerously hot or anything like that. And of course, depending on how much current you put through it will depend on how hot it gets. Now, so I want to make this cheap and available to everyone, and so if you have any ideas, please, constructive ones. I mean, be critical. I don't really care. I'm just going to... I think I'm pretty immune now to people just saying, what are you doing, you idiots? Why haven't you done this? I don't care. Even if you put it like that, why haven't you done that? I'm just going to ignore your negativity, but I'm going to read what you've suggested. I don't care, but please try and keep it constructive if you can. It just makes it easier. I don't have to then deal with the psychological toll of the kind of negative elements of criticism. But if you do have any ideas then on how I could improve this or how it would work better for controlling mushrooms, just let me know, because I want to improve this and make this better and make this an open source project and make it a decent thing. So that's it really. Well, I just want to say thanks again to everyone on Hackvana for helping me out with the PCB and stuff like that, and everyone else that's helped me in that regard, and especially to Robert Murray Smith for really being an inspiration in terms of building this product, and for being so open and helpful in helping me with the ink and so on. I mean, I think it's just fantastic. It's a great collaborative spirit, and I really hope I can help Robert out in testing some of his products like this ink by hopefully developing uses for them, you know, or the ones that I personally can think of, and try and use these new technologies, because it's pretty harmless really. It's just carbon, you know. There's nothing, you could make these things really bio-friendly. And I was thinking about the box. This is MDF. It's not very bio-friendly. What I want to do, which is a little bit bonkers, is actually grow a box using mycelium. Now, people have done this before, mainly for art installation and things like that, and people are growing packaging using mycelium. So I want to try, probably using oyster mycelium, maybe something else, I'm not sure yet, to see if I can grow panels, dry them out, cover them in a lacquer. And Robert, again, has some fantastic chemistry ideas for making actually biodegradable foams for insulation and things like that. So I think we could have some really cool stuff going on here if I can, you know, motivate myself to do it, which I'm pretty sure I can. Anyway, that's it. So thank you for listening, and hopefully you've learned something about mushroom growing even, and that you can get some idea of what I'm doing with this project. And as I said, any comments you got, I'd love to hear them. Thanks a lot.